Hello guys, it's your boy Jibok back and active. Don't be kidded. In this video, I'm going to be solving UI past questions on Physics 101, and I'm going to be solving it from the latest to the oldest past question. So this is just one of the videos I'm going to be dropping on Physics 101. So let's begin. To get the questions I'm solving, to get the past questions, the link is in the description below, so you can download the past questions. The past question I'm going to solve, you can download it in the description below of this video. So let's go with question number 1. Question number 1 says, which of the following statements is false? A. Sinusoidal functions oscillate between minimum and maximum values at regular intervals. We all know that option is correct because sinusoidal functions are functions that repeat their values at regular intervals. Just like this, they repeat their values at regular intervals. So option A is correct. Option B says periodic functions include sine and cosine functions. Yes, sine and cosine functions are sinusoidal functions, and sinusoidal functions are periodic functions. That option is also correct. Option C says all periodic functions are sinusoidal functions. That option is not correct because all sinusoidal functions are periodic functions, but not all periodic functions are sinusoidal functions. So option C is our correct answer. So number 1 is C. Option D says periodic function repeats shape at regular intervals. That is also correct. It repeats shape at regular intervals. So number 1, the answer is C. Number 2, they said if the relationship between a physical quantity and another physical quantity, a physical quantity V and another physical quantity J, is given by PV is equal to J raised to power gamma. That's why where P and Y are constant, when the graph of log V is plotted against the graph of log J, which of the following statement is true? We have to simplify this thing, and we'll simplify it using logarithm. So we'll log both sides. That will be log PV is equal to log J raised to power gamma. So that will be log P. When you open this bracket, that's log P plus log V. And if you simplify this, according to log V, this is log J raised to power gamma. So according to logarithm, when we have log xy, it can be written as y log x. So you can bring this gamma here, that will be gamma log G. So what we want to do is to write this equation in a way it resembles the equation of a straight line, which is y is equal to mx plus c. We want to write this equation in a way it resembles this one. So let's go. So they said we should plot, they said log V is plotted against log J. They said log V, the graph of log V plotted against log J. That means log V will be in the y-axis. Log V plotted against log J. Then this will be the x-axis. Then we'll rewrite this log J. Then we bring this one to the right hand side. That will be minus log P. And now it resembles the equation of a straight line. So this is our y-axis. This gamma is our slope. Log P is our intercept. So let's look at the options. Option A says y will be obtained, that's gamma. Y will be obtained from the intercept of the graph. No, because y is the slope, so it cannot be obtained from the intercept. P will be obtained from the slope of the graph. P is our intercept, log P is our intercept. No, so B is false. B is not correct. C, they said P is negative. P is actually negative, you see, because of this negative sign. So that's our answer. And they said y is positive, we can't know if the slope is positive or negative. So the most correct answer will be C. P is negative. So question number 3 says, which of the following statements is false? Question number 3. A. Physical quantities are measurable. Of course, that's correct. All physical quantities are measurable. Physical quantities has to be measured. For a quantity with physical quantity in physics, it has to be measured. Number B. Option B said all units of the same dimensions are related to each other. That's correct. All units, if a quantity have the same dimension, if two quantities have the same dimension, or they have the same units that are related to dimension, they are related to each other. Option C says measured quantity without its unit of measurement has no meaning. Option C is actually false, and that's our answer, because when a quantity is presented without a unit, it does not have complete meaning. Not like it does not have meaning at all, but it does not have complete meaning. But the option says it has no meaning, so that's wrong. It has meaning, but the meaning is not complete. So if the option has presented it has no complete meaning, yes, you have been correct, but it said it has no meaning, which is false. So our answer is option C. Option D said all quantities in mechanics are derived by the combination of only 3 fundamental quantities. Yes, that's correct. And the fundamental quantities are L, M, and T for mechanics. I've explained this in one of the video I uploaded on dimension. So question number 4. Question number 4 says if x and y have different dimensions, which of the following operations is or are possible? They said I is x plus y, I is xy, I is square root of x minus y, and IV is xy inverse. Then I said which of the following operation is or are possible? Since they have different dimensions, had it been they have same dimension, now we are going to use principle of homogeneity, which says if they are separated by plus or is equal to, that means they have the same dimension. But here they have different dimensions, so they must not be separated with plus. They can be separated with all other signs like division, multiplication, but they cannot be separated with plus. But here they are separated with plus, which means this one is not there. This one is not correct because they have different dimensions. Here they are separated with product, that means this one is possible. Here they are separated with this sign. This one is also there. This one is also there, and they are also separated with even this. I'm not sure this is not there. Why here they are separated with product sign? This is also there. So our right option will be option B, II and IV. That's the answer. Question number 5. They said according to Newton's second law, F is equal to ma. F is equal to ma. And from gravitation, F is equal to G m1 m2 over r squared. Now, so what is the dimension of G? I've done this before. So the first thing to do is make G the solid of the formula. That's F r squared over m squared. And you look for the dimension. The dimension for force is m LT minus 2. That's mass times acceleration. Times radius. Radius is length. That's L squared over m squared. Mass. So this will take this out. So the dimension for G will be, you will bring this one up, that will be m raised to power minus 1 L cube L cubed plus L raised to power 3 and T raised to power minus 2. So if you check the option, the correct option there is option B. Correct option there is option B. So that's the answer. So let's move to question 6. Question 6, they said if V is equal to WA sine K over M all raised to power half T. They now said find the dimensions of W and K. Find the dimension of W and K. So this is very easy. Actually, this is very easy. Don't look at the way it is scattered or the way it's complex. It's very easy. We all know that the dimension of angle is dimensionless. Dimension of angle does not have any dimension. So if angle does not have dimension, this sine theta, everything is dimensionless. And if something is dimensionless, that means it has a dimension of 1. The answer is 1. It is dimensionless, it is a pure number. So that's everything here is 1. So everything like this, you see I writing V is equal to WA. Because all these things like this dimensionless, so everything is still 1. And WA times 1 is CWA. So we just look for the dimension of WA. You don't know that V is velocity. They gave it the option, said V is velocity, A is length, amplitude is length. So this LT raised to power minus 1 is equal to times length. This will cancel this. W will be T raised to power minus 1. So we've gotten W T raised to power minus 1. As we've even gotten W T raised to power minus 1, you can just use it to eliminate all other options and you find out that your option is option D. But let me show you how they got the dimension for K. Anything hey, yes, I just clean the option. Alright. So how did they get the one for K? Since we said everything here is 1, we can just equate it to 1. That will be sine K over M raised to power half dot T is equal to 1. And this sign, you can just consider it as a constant and just erase it because this is dimensionless. This is dimensionless. You just want to, it's just this angle we want to consider. So we can take it like this. This is square root of K over M. So we can just say square root of K over M. Square root of K over M is equal to, when you bring T to this other side, it will be T raised to power minus 1. You can square both sides and you get K over M is equal to T raised to power minus 2. Because when you square this place, it cancels the square root. And when you square this place, it gives T raised to power minus 2. So K will be M times T raised to power minus 2. So that's how they got it. And you can see that the option is option D. The answer is option D. The answer is option D. So question number 7. It said a boy walks 4 meters east. These are 4 cardinal points. This is north, this is south, this is east, and this is west. So it said a boy walks 4 meters east. This is 4 meters east. 4 meters east. And 3 meters south. And 3 meters south. They said they said find the magnitude and direction of his displacement. Find the magnitude and direction of displacement. So let's do like this. If it works 4 meter east, then it works 3 meters south, directly south. Find the displacement. This is the displacement from A to B. This is displacement. So to find the displacement, we just use Pythagoras theorem. That will be 4 squared plus 3 squared. Then R will be square root of 4 squared plus 3 squared. 4 squared is 16. 16 plus 9. And that R is equal to square root of 25, which is 5. R is 25. R is 5. So square root of 25 is 5. So the displacement is 5 meters. That's the magnitude. So what's the direction? Then to get the direction, we need to draw it here. So what's the direction now? You want to get, this is what you want to get. As to get this, you can just use tan theta. So that's tan theta. Tan theta is equal to opposite of adjacent. This is opposite of adjacent. That's 3 over 4. Theta will be the arctan of 3 over 4. The arctan of 3 over 4. And as theta is equal to, let me do arctan of 3 over 4. So arctan of 3 over 4. And that's 36.87 degree. That's 36.87 degree. So this 36.87 degree, 36.87 degree. So option says 5 meters southeast, B 53.33 degrees southeast. If you notice that everything is in southeast, but this is not southeast. Southeast means east of south. So the angle belongs to south. So what do? We do 90 minus our answer. That's 90 minus 36.87. And that's 53.13 degrees. So the angle is the direction of the magnitude is now 53.13 southeast, because our angle needs to be in the south since the option is in southeast. So that's 53.13. And to the option, the answer will be option B. So that's what has 5 meters and 53.33 degrees southeast. We got 53.13. That's just decimal error. That's what 53 point something is there. That's the answer. So question number 8. They said an insect walks 50 centimeters in a straight line along a wall. If its horizontal displacement is 25 centimeters, what is the vertical displacement? If an insect walk in a straight line, it doesn't necessarily mean it's walking maybe vertical or it's walking horizontal. This is also a straight line. A slant line like this is a straight line. As far as it's straight, it does not necessarily mean it's walking in vertical direction or horizontal direction. If it's walking in vertical direction, it will indicate, but it's in a straight line. So this can be a straight line. It now said if its horizontal displacement is 25 centimeters, then this is the horizontal displacement. The horizontal displacement is 25 centimeters. The horizontal displacement is 25 centimeters. What is the vertical displacement? We have to find this, the vertical displacement. And the straight line it worked is 50 centimeters, right? It worked 50 centimeters. So what is this vertical displacement? Let's call the vertical displacement V. The vertical displacement is easy. We just use our normal Pythagoras theorem, and that will be V squared is equal to 50 squared. 50 squared minus 25 squared. Then that will be square root of 50 squared minus 25 squared. Square root of 50 squared minus 25 square, I will get that. So let's do square root of 50 square minus 25 square. That will give you 25 root 3, which is 43.3 centimeter. So our vertical displacement is 43.3 centimeter, and that's option B. 43.3 centimeter. So that's the vertical displacement, and that's option B. I'm going to 30 questions, and we're seeing on question 8. So question 9. It said a body slides down a smooth plane. This is a smooth plane. A body slides down a smooth plane inclined at 60 degree. The smooth plane is inclined at 60 degree. Right? Find the distance covered after 5 seconds from rest. Distance covered at 5 seconds from rest. So this is the formula to use. Is S is equal to ut plus half gt squared. But since it is coming from rest, this formula is ut plus half gt squared. But since it's coming from rest, then u is 0. And u is 0. That's, we'll be left with s is equal to half gt. Sorry, half at squared. It's actually half at squared because it's not directly under gravity. So that's half at squared. But looking at this scenario, our acceleration is g sine theta. Our acceleration is g sine theta because it's moving in this direction. This g sine theta. This g sine theta. If it's going down, if I consider down, that will be g cos theta. But we are not worried about that. So if it's moving like this, acceleration will be g sine theta. So that will be s is equal to half g sine theta t squared. I'll just plug in the value and get an answer. So s is equal to half times g is 9.81. 9.81 sine 60 times sine 60. That was like 0.8660. 0.860 times 5 square. The time is 5 seconds, right? Time is 5 seconds. Yeah, so that's 5 square. And our answer S, the distance will be, I'm present the calculator, as half g sine theta 9.81 and 8.8660 times 25. So the answer is 106.25. That's the answer. Option E, 106.25 meter. 106.5 meter. So the answer is option A, question number 9. Question number 10. It says find the minimum velocity to hit a target of 755 kilometers away. 755 kilometers away under gravity. So this is a question under projectile because they are asking for minimum velocity, and at minimum velocity the range is u square over g, because at minimum velocity the range is maximum, and that's, if the range is maximum, then theta is 45 degrees, and that's sine 2 theta, that's sine 90, and sine 90 is 1. So r is equal to u square over g. And that's why you should look for the minimum velocity. Our range is 755 kilometers. That's 755 times 10 raised to the power 3 meter is equal to u square over 9.8. Over 9.8. Then let's calculate the velocity. That will be 755,000 meter and 9.8 square root of the answer. That's 2,000 2,720 meter per second. That's 2,720 meter per second. And that was option A, question number 10, option A.